All right, so our last unit that we're going to start here is quadratic expressions and equations. Hopefully you've already put your name on the front of your packet. And as always, then I have the bell schedules, table of contents here. We are going to get right in that graphing quadratic functions. We are going to start today. Yep. So we're going to put 11/15 as the date there. And then we're going to stay on that page because we need to do our essential questions for this unit. Now, before we get to the essential questions and you look at those topics, what is one word that you keep seeing over and over in that table of contents?
Quadratics.
Besides quadratics?
Solving.
Solving. This is what this Unit 2, we learned about the quadratic function. Now we're going to learn how do we solve it and what does it mean to solve it. These are things we're going to be learning in this unit. So if we go down to the essential questions, the first one. What are the advantages of a quadratic function in vertex form versus standard form? What are the advantages of a quadratic function in vertex form versus standard form? And if we were to write that out in equations, really it's asking us the difference or the advantages of f of x equals a times the quantity x minus h squared plus k versus f of x equals ax squared plus bx plus c. That's what we're going to be comparing. We've done a lot of work with the vertex form on the left. This unit, most of our work is going to be done in standard form on the right. We will learn in this unit how can we go from standard form to vertex form. There's a little bit of math that we have to learn how we can make that happen. And there are advantages to each form, and it depends on what are you trying to do. Question number 2. What are the similarities between factoring and solving? And then the third question, which is really one of the most important, what does it mean to solve a quadratic equation? So again, these are the things that you should be able to answer by the end of this unit. All right, so let's go to page 7 and start that first activity for today. So I know that we did some graphing of quadratic functions back in Unit 2, but when we were graphing back in Unit 2, we were using the vertex form. Now we've got to learn how can we graph when it's in standard form and what the changes are. This first diagram should look familiar to you. I used this exact same diagram back in Unit 2. The reason I'm coming back to it is there was one of these boxes that I told you in Unit 2, hey, we'll come back to that. And that's what we're coming back to here in Unit 3. So 3 of the terms we've been using quite regularly. The top right box is pointing at the U-shaped graph, and we know that that U-shaped graph is called a parabola. The box on the top left-hand side is pointed to that dashed line, and we know that that dashed line represents the axis of symmetry. It is your notes. You can put it how you would like. And then that bottom left box is pointing to the lowest point, and we know that as the vertex. So those 3 terms we've been using, we're going to continue to use. There is nothing new in those terms. It's this 4th box. I gave you these terms in Unit 2, but I said, hey, I'm just giving you the terms. We're not going to talk about them. We will come back to them later. And again, this is the later that we're coming back to. So in this box, it's pointing to those 2 points that sit on the x-axis. And there are 4 different names that we can use to talk about those 2 points. The most obvious being x-intercepts. Those are the 2 points where this function crosses the x-axis. But when we're referring to quadratics, there are a few other terms they use that really mean the same thing. You will also hear them ask for the roots of the function. If they ask you for the roots of the function, they're asking you what are the x-intercepts. If they ask you for the zeros of the functions, they are asking you for the x-intercepts. And if they ask you what are the solutions, they are asking for the x-intercepts. So all of those topics you said that you saw about solving, all of those are asking us, where does the function cross the x-axis? That is the solution to a quadratic formula. Is the point, it could be 1 point, it could be 2 points or no points, and we'll talk about that a little bit further down the line. But it is all this box here that's really going to be the star of the show in this unit. This is where we're going to get to how do I find or how do I solve a quadratic function? So again, you've seen the diagram, we've talked about the terms, but now we're really going to focus in on that bottom right-hand box and learning what does that mean, how can we do that. All right, so again, this vocabulary, most of it is vocabulary we've already been using. Just want to make sure we have a clear understanding. So axis of symmetry. The invisible line that divides a parabola in half. The invisible line that divides a parabola in half. And I call it an invisible line because remember, we always draw it as a dashed line because it's not part of the function. It's just a line that helps guide us through the function. And the vertex always lies on this line. Again, nothing we haven't already talked about before. Vertex, either the lowest point which means the graph opens up, or the highest point, graph opens down, always lies on the axis of symmetry. All right, the next terms, maximum slash minimum, refer to where the vertex is positioned. Refers to where the vertex is positioned. Maximum when the vertex is at the top of the graph. Minimum when the vertex is at the bottom of the graph. The next word, intercepts. Now we are going to be talking about both x and y intercepts. X-intercepts, again, are going to give us the solution. Y-intercepts just help us with the shape of the function at times. So intercepts is where the graph of the function crosses either the x or y axis. Where the graph of the function crosses either the x or y axis. So I know all of those words up till there we have talked about at some point this year. The last one, end behavior, we haven't really talked about in here yet. It might have been mentioned briefly in Math 1. We're not going to do a whole lot with end behavior, but again, we'll talk about it here. It does become more important when you get into Math 3 and higher on how your functions behave and understanding what that means. So end behavior is really which direction is your function moving on the left and right hand side of the graph. So which direction is your function moving on the left and right hand side of the graph. All right, so now let's scroll down and look at some examples using some of this vocabulary here. So it says identify the axis of symmetry, the vertex, and the y-intercept of the graph, then describe the end behavior. So they're giving us the graph of the function and they're asking us to find some things here. So the first thing they want is axis of symmetry. And we know axis of symmetry always has to be x equals some number. In this case, we need to know what is this number here that is going through the vertex. That's where my axis of symmetry is. That is what is cutting this function in half. So what number would we say x equals what? -2. It's going through that -2 on the x-axis. So our axis of symmetry is the line x equals -2. Now they want us to name the vertex. Now, something with this, I let you guys be a little bit lazy in Unit 2 and I shouldn't have. When you are writing any ordered pair, it doesn't matter whether it's the vertex or some other ordered pair. But anytime you are giving me an answer of an ordered pair, it needs to be in parentheses. Just putting one number, comma, another number does not mean it's an ordered pair. The parentheses are what tell us that is an ordered pair, not just two numbers separated by a comma. So we have our vertex up here. I'm drawing this point in green. What would be the ordered pair that would represent that point? Yeah, so parenthesis, -2, comma 8. Make sure you're putting your ordered pairs in parentheses. The third thing they ask me for is the y-intercept. In other words, they're asking me at what point does this function cross the y-axis? So I just put that point in purple. What would be the ordered pair for that point?
0, -4.
0, comma, +4. It's up. So it'd be 0, comma 4. Now, before we get to the last question they asked, why do you think they didn't ask me for the x-intercepts here? Well, there are x-intercepts because remember, x-intercepts simply mean where does it cross the x-axis. So the function definitely crosses the x-axis. But can we see clearly at what point the function crosses the x-axis? No, and this is where all that solving we're going to learn is going to come in handy. We're going to learn how to find that through solving. Now, if we were doing this on a graphing program, such as Desmos or something else, then we would be able to find out exactly at what point it crosses. We are going to learn how to solve by graphing, but honestly, solve by graphing would be one of my last choices. I would only solve by graphing if that's what they asked me to do and gave me the graph to do it on. Otherwise, it's not the most productive. Okay. But now let's talk about end behavior, because that's the thing they asked me last is what is happening? What is the end behavior? And basically what they are asking me for in this end behavior is if I look at the arrows, in this case, I'm going to darken them up here in orange. It's asking me what is happening on the left side. Those arrows are going down, so that means it's falling. On the right side, those arrows are going down, so it's falling. The good thing about a parabola, the left and right hand side of the function is always going to be doing the same thing. Now, again, this idea of end behavior isn't just for parabolas, it's for all kinds of functions, so it could be different. But the good news for us, it's always going to be going in the same direction. It's either going to be rising or it's going to be falling. So what we would say is on the left, the function is falling. On the right, the function is falling. So end behavior is really just asking you, where is your function going? And you will get to functions where they move in opposite directions. You could get into functions with all kinds of things, but for parabolas, they have to be moving in the same direction because it either opens up or it opens down. Question number 2. So again, we're going back to axis of symmetry. We know it's going to be x equals some number. The question is, what is that number going to be for this function? Where are we getting, not where, remember, don't confuse vertex and axis of symmetry. We're looking for the x value. 0. It's on the y-axis, which means x has to be 0. So in this case, our axis of symmetry is x equals 0. Now we know our vertex is on the axis of symmetry. The y value is 3. So my vertex is 0, 3. Again, it's always, vertex has to be an ordered pair. I know with the y-intercept and even the x-intercepts we'll be learning. In the ALEX program, they only asked you for the number. Here I am asking you to write out the ordered pair. I know it is a little different. All right, the third one here, the y-intercept. Where does this function cross the y-axis?
3.
Yeah, so it's the same as what? The vertex. In this case, the vertex is the y-intercept because the vertex is on the y-axis. So my y-intercept is also 0, 3. And for my end behavior, in this case, my parabola is opening upward, so both sides of it is rising. So on the left, the function is rising. On the right, the function is rising. Again, when we're talking in behavior, we're looking for where are those arrows pointed? Are they pointed up or down? Down, it's falling. Up, it's rising. All right, now we need to talk about standard form a little bit more. I introduced the idea of standard form to you, but we haven't really done a lot of work with it. When we were learning to graph with vertex form, we were basically gifted the vertex and the axis of symmetry, why it's called vertex form. We didn't have to do any solving. We are not so fortunate with standard form. It doesn't gift us the points right off of it. The good news in standard form, the A value has the same jobs. The A value tells us whether it's opening up or down and how wide it's going to be. So the A is the same from vertex form to standard form. But that is the last similarity. Because if you remember in vertex form, we had H and K that gave us the vertex. B and C do not give us the vertex. You can't say, oh, I just need to know the value of B and C. So we need to learn the steps of how to find this. So when you are in standard form, to find your axis of symmetry, there is a formula. You can use x equals negative b divided by 2a. So the opposite of b divided by 2 times the value of a. That gives us our axis of symmetry, which that's the first step, because if I know that x equals some number as my axis of symmetry, I also know that my vertex has to share that same x value. So use the x value from the axis of symmetry. And substitute it back into the equation. And solve for y. So there is going to be a little bit more work here to get the information that we need to be able to graph from standard form. How to solve for the y-intercept. When you think back to questions 1 and 2 that we just did, what do both of those ordered pairs have in common? For both y-intercepts from questions 1 and 2, what do they have in common? We go back up to question 1 and 2 here. I look at both of my answers to the third question. What do both of those ordered pairs have in common? The one on the left with the y-intercept was 0, 4. The one on the right is 0, 3. What do they have in common?
They both have the same
They both have the same x value. They both have 0. When you cross the y-axis, your x value has to be 0. So the ordered pair for the y-intercept is 0, comma, some y value. So to find the y-intercept, I just need to put 0 in for x. That's going to tell me the number. So substitute 0 in for x and solve for y. So again, when we are working in standard form, it is going to take a little bit more work to get the information we need. It's not gifted to us like vertex form. That's why we like vertex form so much for graphing purposes, because it gives us the information we need. The problem is vertex form is not always easy to find the solutions. So it depends on what we're being asked to do with the information. When it comes down to finding solutions, it's actually usually easier from standard form. And there's, as you saw in the table of contents, many different ways to make that happen. And we will talk about how do you know when to use which method, because you're going to see several methods there. And then we have talked domain and range already, but let's just redefine them. Remember, domain is all of the possible x values of a function. And what did we say is always the domain of any parabola? Yep, domain of any parabola is all real numbers. And in other words, what that is telling us is there is no restriction on the values of x that I can put into the function. Now, range is all the possible y values of a function. And the range depends on the y value of the vertex. So if this opens up, it's going to be y is greater than or equal to the y value of the vertex. If it opens down, y is less than or equal to the y value of the vertex.